Project.
Yeah.
So I know we have to create like a single PDF of the exam. Do we have to create a single PDF of all the solutions too?
Probably easiest if we did.
Okay, yeah. Yeah, I just wanted to know.
Yeah, if you can just combine them all into one, it's great. It's easiest. So it has the problem and the solution. All right, welcome. So tomorrow is going to be due your group or individual work for preparation on the exam. So exam is going to be on Wednesday. And so do prepare for that. I have posted some notes for today for those that have access to online. You're welcome to grab those. So it's this exam one review is what we're going to go over. Okay. So the group individuals, so if you're in a group but haven't worked with a group, if you can just move yourself down to the individual groups and do your own work. Even if you don't move yourself down, you're welcome to still do the individual portion of that preparation. Exam on Wednesday, it will be open notes, open book. You can use online notes, online calculators. MATLAB is also okay. If you have any pre-written software, so if you do use MATLAB and you have some pre-written code that you plan to use, feel free to use those, but do take like a screenshot of what you're using and then put that in your work that you submit, okay? So just in case you have errors in that way you can also be graded on that as partial work. What you cannot have is no simulators. So no circuit simulators, no online tutoring support systems such as Chegg, Course Hero, any of the others that are like that. No help from other individuals in any way, no communication to others during exam time. So all of those no listings are considered cheating. And so I'm going over them to make sure everybody's clear. Just do your own work. All right, questions about that? Yes. Python's okay, yes. So if you want to use Python again, just take a screenshot of your Python code. And just include that in your uploaded work. So if you use Python, C, Java, whatever, if you use software or MATLAB, and you have any code that you write for it to solve for it, just take snippets of that and include that in submitted work. Okay. And you are welcome to use those if you want to pre-code things, just like pre-coding things in your calculators you can code, you're welcome to do that too. Location for in-person will be in the Ingman lab. It's in this building, just upstairs 1 floor in the L210. You're welcome to also, some of you have your own computers that you like to work on. You're welcome to bring your own computer and just work on that during the exam. The only thing for both in-person and remote is that you're going to need to tile your windows that you work on so that every window can be seen on your screen. And then no browser window should have multiple tabs on them. So it should just have it all on one screen. Remote is also an option if you do attend remotely, that there will be possibly a verification step with that. And so I'll reach out individually if you do a remote attendance for that. Again, you'll need to tile your windows, no multiple tabs. And then for online, you have to have your camera on and your audio on during the exam. Note for those that are online, or if you are remotely going to be attending that, I will put you in probably a separate room and be recording that room during the same time. So do bring scratch paper to work on, calculator, or prepare to have it be the online version, and a way to upload your work. There is a scanner available in there that you can use in the lab, but if you're used to your own way, a lot of you have it on your cell phone, which is easy just to snap it. Do bring whatever you plan to use for that. So also note that credit may not be granted if your answer is not the same work shown. I don't know how this happens, but I've had a few individuals in the past that, if it's a typo, it's fine. But if your answer is correct online, but your work doesn't justify it, there is a possibility you won't get full credit for it. So do make sure that you do submit your work and that it does show and line up with what you've put in as your answer for the exam. All right, any questions so far about attendance, where it's going to be? Yes. Yes, open notes, open book. If you have online notes, a few of you said you have online notes that you're keeping, that's fine to use. Just again, tile it in your window. If you are bringing another device, like you have an iPad, just note I will ask you to show like what other apps may be open in that. So, any other questions? Okay, clear about where the exam is. Okay, content on the exam is going to be an RL circuit, RC circuit, RLC circuit, or 2 circuits for RLC, and then concept question. Yes.
The individuals that said to do 2 problems on homework. Do we do 2 of each type of 2 total?
Pick which other, just 2 total. So yes, if you're doing an individual group, you don't have to do all 4 of those. Well, it's mainly 3. You can just pick 2 of the ones that you feel that you need more work with. Okay. And then individuals, I do encourage you to upload as quickly as possible so you can get feedback from others, since you haven't worked in a group, and maybe they can point out, oh, you might have done this wrong or not. So you can get some feedback before Wednesday. So while it's due on Tuesday, feel free to upload it at any point. Okay. Any other comments, questions? Yes.
are the values gonna be like pretty easy to do math with, or?
No,
um,
no, they're gonna be very similar to what you've seen, because that's gonna be, they're still gonna be randomized, so they're gonna be unique problems for everybody.
Okay.
And so they may be weird numbers in there.
Alright.
And that's just because the computer will auto generate them. So we can have pretty much everybody hopefully has a unique exam.
Will it be the same shape of circuit for everyone? Just different values?
Yes and no, I try and do several different problems, so the circuits may look different.
And then it's similar part of it.
I try and keep them about the same level. But yes, I try and do different problems or different circuits too. So hopefully my goal is to try and get everybody have unique problems, so nobody really can cheat off anybody else, even if there is communication that shouldn't be done. But with that being said, I do try to keep them the same level of difficulty. Yes.
Does that mean we're gonna receive our exam score as soon as we get submitted?
Yep. So you'll see if you have right or wrong. Yeah. So you will see, just like with the quiz, it will be like, yes, you got it right or wrong. And then I try and have that tolerance in there for the values. So even if you're wrong, though, if you submit, you know, the partial work, then it can be seen, like, and you'll get feedback as far as what you may have done wrong. But yes, it will be an immediate feedback. All right, any other questions? Okay, and then also note, like, you'll have an opportunity, if you don't do well on this exam, you have an opportunity to retake it as the final. So my goal is that you continue to learn, like, what are you not doing correct, and how do you learn from that, and how do you grow and do it so you can learn how to do it well. Okay. But hopefully all of you are going to do well and not have to take the final portion, right?
Yeah.
That's the goal, is just do well now. But some of you with your learning styles, it may be helpful to do it the other way. So just use this as like, okay, I know myself, and I know I'm not usually like super good at, like, I may not have it fully yet, but by the end of the semester you will. And so you may be like, that will be great. All right. Okay, first circuit we're going to look at is a RC circuit. And so switch will be closed at t equals 0. So end up writing the equation for V2 of t. So go ahead, you guys can work in small groups. And we have Katie and Sean here today. Thanks, guys, for coming. And they're going to help wander around too and see if you have any questions as they go. Yes. Uh-huh. There's another.
Right, the second day of the parallel value going on. That means here.
That would be a true statement.
Yeah. Right. Go together. This turns into 7, that would be the girl of this. 20K plus 21.
Yeah.
Because we're so used to having.
20s.
So.
All right. What you're saying is like, this is what I'm thinking, so, where I'm thinking that it's more wide, and I'm thinking it's more wide. Okay, is that what it is?
That's what. Then.
Yeah, the 21. You need to look at Zero. Don't have to do all of it.
Thank you.
We should just do that.
This again. Because this is what we were thinking. That's what I understand. So. It will be 5. I don't think that. Yeah, because there's a lot here, because we're thinking here, but we need to know what the right here. This is actually some drops. Because that's what we're thinking, like this, we're thinking that looks like this. That's.
Yeah, you see 0.
You know, there's a bolt drop here.
Oh, because the switch.
Okay, so it's almost. I mean, it's like it's almost. There's like. Yes. Right. We die.
But then you just do minus.
Well, I didn't realize that this you can't see it, right?
Wait. So that's 0. So not gonna get that. I guess, yeah, because that's gonna be the most. Yes. Because if the ground right there. Somebody needs to use this. Exterior. It's 7. Just it makes the ECE a little easier.
Well, we're gonna do it.
Yeah.
Oh. We can debate about our. Self about the. Yeah.
So in the final. Let me just say. Reading that whole ball. Yeah. Because you would end up doing this information.
You can do both.
You got 1.7.
So can you just say that on the strength that is
Oh. It's good that it passed.
The four these will be in series. Okay, so everyone needs it's all. Well, I think it would be Oh, I think you're. If you go into your base state.
41 divided by 70 is what left to do that. 42 divided by 70 plus I tried, I did mine, I did mine in different ways and you can find. We got this. Yeah.
You're now. Oh, yeah.
Yeah. Yeah, that's right here. See that? So. Well, that would be here, which. I did it right. Yeah, I just know it's like yeah, so this like, yeah, this. I made like nine. I would do like yeah. Yeah. Yeah, it is.
All right, so let's go through this solution. Have you guys finished?
Yes.
Got some yeses, others yes, okay. All right, so the final form that you're looking for both RC and RL is this final value plus initial minus final times e to the minus, oh, sorry, that was a t. My 5 got in there. Minus t over tau. In my lecture 3 notes, another person was pointing out that it didn't have the parentheses correct. So make sure that you have this equation down correct, that it's final alone plus the initial minus final is multiplied by e to the minus t over tau. All right, so we need to find initial value, final value. Initial value is which circuit? Or which time, I should say. So initial, you're gonna use 0 minus to find 0 plus. So in this case, the capacitor value is going to be the same at 0 minus and 0 plus. So you can use the 0 minus. But if you are finding something else, do note that that always is going to be at the 0 plus time, right after the switch has been switched. So initially it sat there for a long time. The switch was open, and then this was sitting open. So V2, which equals VC, is going to be what for initial? 0, correct. All right, so that's the same at 0 minus and 0 plus, so that'll be it. If it was 0 plus, I would replace that with voltage source, and put in that 0 volt and find whatever value I'm trying to find for that initial value. All right, for the final, I note that this is going to be 0 because it's open. And so if I called this Vx, Vx is going to be the same as the Vc here because of that no current in that branch. So again, you know me well to know I love to do node voltage. So Vx over 7K plus Vx minus a minus 2 over 3K. And then there's 0 in that other branch. So this would be my node voltage equation. Let's see, plus plus becomes a minus. And this ends up giving me a value of minus 1.4, was that?
Yes.
Yeah, minus 1.4. All right, other ways I could have solved that? Other ways anybody else solved it?
I just did a KVL. It's the retail one. It's affected that 2 volts.
Okay, so you could find, there's only one branch, so you could do, all of this is going to be the same current. So you could do a loop, solve for the current, and then the voltage across the 3K. So I times 3K minus 2 also gives you that Vx. So that'd be another way to do it. Any other ways? Anybody else solved it? It's also a voltage divider if you identify it as a voltage divider. Okay, so you do is the voltage division. So if you notice it's a voltage divider, you could also use a voltage divider equation. All of them should yield the same result. So if you notice it's something, you can also solve it one way and then check doing it the other way. All right, final circuit. It is closed again for this one. So tau is remove all of the sources. So voltage goes to 0, so wires, and current sources become open. And then you take your path from A, it goes through the 20K, but then it splits at that location. So that means that it's going to be 20K plus the 2 branches in parallel with each other. And in one of our branch, you see it's just 3K, and in the other branch, you see it's 4K plus 3K. So this ends up giving 22.1K. And so tau in this case is RTH times C and 0.884. So final value of minus 1.4 plus initial minus final. So the minus becomes a plus, E to the minus T over tau of 0.884 in volts. So this would be my answer. All right, yay, nay. So I'm seeing some yeses. If you didn't get it, any questions? Or if you did get it and still have a question? Okay, guys ready to move on to the next one? Okay. RL this time. Or IL, I mean. RL.
So like it's like model is zero from that. Yeah. Alright, so I would say, you know, it's yeah, that's the good part.
Yeah, I guess it's not might be. It just short. You're like, my God, it took us too long to figure it out. Yeah.
Does that help? Okay. Yeah. No wonder you were confused. Yeah, if that was the case, it's gonna be really confusing.
Okay. So say it does happen like that, then. That's where you have like.
Okay, so finding the initial value. So switch is first in the first position, which is here. And this becomes a wire after it's sat for a long time. So what's IL of 0 minus? 0, correct. And then that also equals 0 plus. So that will be our initial value. The final value is that the switch is now in position 2, so it goes across here. And again, it's sat for a long time, so a wire here. And if I color this, I can see that the same color is on the top and bottom, so this ends up being ignored because there's no current going through there. So the current going through here has to be the same direction as IL. And so I can do plus 12 minus 6 IL and solve for IL gives me 2. So 2 amps is my final value. And then for tau, I remove, or I set 0 the sources, so that becomes a wire for this source of 12. And then as I take my pathway here, I go from A and I see that it splits. So that means that I have 2 branches in parallel. And so 6 ohms is in one branch and 3 ohm in the other. And so that gives me a value of 2 ohms. And so it was 1 Henry, so 1/2 for tau. And then IL of t is going to be the final value, which was 2. 0 minus 2 e to the minus t over 1/2, which becomes 2. Right, it is 2t minus 2t. In amps, t greater than or equal to 0. So that will actually be 2 minus 2. So it will be this one here. Have you guys seen this U of t before? Anybody knows what that means? No. So U of t is called a step function. And all it does is mean at time equals 0, it does a step up to 1. So it goes from 0 to 1. And so it's another way of writing t greater than or equal to 0. It just means anything after time 0 or greater, equal or greater, it will have the value of whatever that equation is. So that means the same thing as 2 minus 2e to minus 2t, or t greater than or equal to 0. So those two mean the same things, whichever way you like to write them. So whenever you see U of t, it just means for time, any time on this equation that's greater than or equal to 0. Okay, questions? Is that pretty straightforward? Okay. Next one. Okay, so move into RLC. So steps again for RLC, determine series or parallel, calculate alpha omega naught. And then from there, you can define if it's overdamped, critically damped, or underdamped. And then use the equation sets and find the variables within there for if you need S1, S2, omega D, and then the initial value and the final values. Okay, so this one is to find VC of T. It's what? So this one, hopefully you do find it in series. So again, how do you determine which is series or parallel? Which circuit do you look at? The final state. So look at that final circuit, and that's the one that's going to determine if it's in series or parallel. What? Sorry, these are in parallel. Sorry, no, they are in parallel. Yeah, I said that and went, wait, it is in parallel. Those two are in parallel, yes. Definitely.
Well, I did it. I did it.
So I'm going to simplify this slightly. So find IL of T.
What's the voltage across the? It would be charged, but it's not there. It didn't drain. That's what we can
Yeah, I got one. This is what I'm all day.
Okay. Fine. Okay, so parallel form. RTH is going to be 5 ohms.
Always.
And alpha, you need to make sure you're using the right equation for alpha as 2 over RTHC. And that ends up being 2 omega naught 1 over 20 times 5 ends up being 2. So critically damped. Okay, so from here, you're gonna find erase this. So now we need to know IL infinity, IL 0, and VL 0. So initial is going to be open, capacitor's open, inductor is a wire. And so hopefully you see IL is just 0. It then stays 0. And then your VL is going to be the voltage across the capacitor, which in this case is 15 volts. So VL equals VC equals 15 volts. Final state, it's closed and closed. So you just, again, do that loop. And so this current here will be IL. And so plus 15 minus 5 times IL. And so IL is 15 over 5 for 3 amps. RTH for the final is again 5 ohms. And so you get initial of 3. Or I mean, final, IL final is 3. And then B1 is a minus 3. And B2 is 1/5 over 1/5 times 15 for BL0. Plus 2, 0 minus 3. And so you end up with a net minus 3 for that one too. And your equation ends up looking like that. All right, questions on this? Any questions? Yes.
So there's two voltage sources, like BL0. We have the capacitor, and then there's what happens to the one on the left? Why is BL0 plus? Those good volts, not like.
So you're looking at this node for the actual voltage. And so the characteristic of that capacitor is that it has to stay 15 volts. So what happens here is you actually drop 0 volts here, right? To make it, whoops. 15 and 15. So that node has to stay 15 volts right at that time that it switched. It can't be anything else because that capacitor is forcing it to. Right after it, it starts to change. Will either increase or decrease. But right at that point, it has to stay 15 because of the capacitor. And so because it's in parallel, it has to keep that inductor also right at 15 volts for that initial value. You don't ignore it, but it doesn't, when you have a battery, and then you have a battery and there's a resistor in between there, this battery is still going to fix that top node to be whatever battery it is. So that's kind of what's going on here, is you have a fixed battery. And yes, there's a circuit that's connected to it, but if I already know this is 15 volts, then I don't need to use anything else to solve for that 15 volts. Does that make sense? Okay. All right, any other questions? Any questions online? Okay. Last one is a series. So find VC of T for this one.
Is it, from what I'm saying, is it like, could it also be like a dropping like 15 volts and interfere with that area?
Well, if it dropped by 15 volts, it would be 0 volts at that node, and it's not, it's 15 volts.
Okay.
Yeah, so the only way it can be that 15 volts is 0 volts across it. That's why I put 0 in there really quick.
Disgusting. We have a reason to be neither. Less. Just more. Alright. Final closure statement. Yeah.
Hi. Yes, thank you. Let me pull that up. I forgot. I forgot about it.
There were two versions of the slides.
Yeah.
Just because my copy. So the version of the slides are correct of a dinosaur.
Oh, okay. Sweet. Was it sent by you or no? I can't see it.
It's like. Review.
Oh, no, that's not. She had a question about the UAC. Sorry, I have so many emails. I forgot. Many emails. This one? No.
Did you not draw it? No, I drew it.
It like didn't go online for me for some reason.
It did start with words this year.
I think it's like, it should be the same name, but with like V2 at the end. In the PDF. And if you don't have. If you don't have it, I can always like resend it to you.
Do you have it with you?
I
Email?
unfortunately do.
Okay.
I have just the QR code.
Do you want to email it to me? And I'll just put it up here and then I'll show that at the end.
Yeah.
Angela.
Hopefully.
Oh, there we go.
Or at least I'm thinking, yeah.
Show these and then I'll. All right, finish solving this one. Students that are online. Taehoon, so you just make sure you have your tables accessible. It will be open notes for the exam. I'll grab that in a second. Okay, so I have a guest that is gonna talk to us a little bit about SWE for a second, and then we'll come back to the solution at the very end. Go ahead.
Hi guys, I'm Anika. I'm the president of the University of Utah section of SWE. You don't have to be a female to be part of SWE. The only requirement, you have to be a female. So if you want to be part of SWE, come join us. Our main goal is to empower women and other underrepresented identities in engineering.
So if you're a male and you want to support females, you can still join.
Yeah. Can you
Oh, yeah.
Cool, and we have a bunch of meetings every week. We have 5 different committees, including our general meeting. So our general committee meeting is called Communiswe. That's where all of our leadership and members come together and we all update each other on what's going on. So if you want to learn more generally about SWE, come to that. It's on Monday, every other Monday, from 6:15 to 7 p.m. in Web 1248, which is upstairs. It's not this Monday, and it won't be next Monday because of this event, but go to that if you'd like more information. And if you would like to, help out with flyers, we have a communications committee that does the flyers and newsletters and everything. Or if you just want to help plan outreach events, we do outreach events through Girl Scouts and also other schools off campus. So if you'd like to be involved in SWE, we have a lot that we need help with throughout the year, and we'd love to have you. Our biggest event of the year, though, is a professional networking event. It's called Evening with Industry. You guys might have heard about it before. Evening with Industry is a great way to expand your network, develop your professional networking skills, and you can also get internships and or full-time employment from it. You guys are probably more in the arena of looking for internships. And I didn't know this until one of Marathon Fund interns came and talked to me in my junior seminar class. But last year we actually had an ECE undergrad get a co-op with Marathon Petroleum. So it is a great way to get some face time with the corporate representatives who will be at the STEM fair, which is the next day at this event. You do not have to be a woman to come to this event. It's open to all majors, years, genders, and this event is probably our most well attended, with male-female distribution. It's a huge event. There's more than 120 students there. We have 30 reps who come from our corporate sponsors, and our corporate sponsors this year include Northrop Grumman, Boeing, Ash Grove, and there's a full list through that QR code link. So if you'd like to check out what companies will be coming to EWI this year, check out that QR code. And like I said, Evening with Industry is a great way to expand your network, develop professional networking skills, and get internships. So if you'd like to come to that event, please go to that QR code and register through there. It is a business formal event, so please wear business formal attire. That just means black pants, nice shirt, that's it. Basically the same thing you would wear to the STEM career fair if you were actually wanting to get a internship from the career fair. And we also ask for your resumes in this Google form, so please be prepared to submit your please be prepared to submit your resume to the Google form if you'd like to come to the event. You don't have to make your resume anything fancy, just update it because we do send it out to our company sponsors in a huge resume book after this event. Do you guys have any questions? Cool. And I don't think I said this, but it's on the flyer and it's definitely in the QR code. The event is from 5:30 to 8:30 on September 26th at the Alumni House. That is the day before, or it's on September 25th at the Alumni House. That's the day before the internship career fair, the STEM internship career fair on the 26th. And if you guys do have any other questions, there is contact information through that QR code. Thanks, guys.
All right, so I'll send the right one with this right QR code to our announcements for you guys to have. Thank you. Yeah, just have her send me the flyer. Okay, thanks. Okay, I will, I'll post the solutions, so you guys can look at those and have those solutions. All right, have a good day.
Yeah, I changed it.